Right then. Right then. Let's see if we can at least get day 3 done. So we were trying to figure out nom, and I've got this ridiculous parser down here with its rather crazy signature. String, string, char, string, char. Or do people say car nowadays? I wonder. It's always been char to me. So we do a take until mol. But what I noticed about that was that it didn't seem to work unless I removed everything else in front of it. So for example, if I run this now, open this up, and we need to do some padding work, but that's okay. So 3, mull it over, and our output is, what the hell is going on with this, by the way? Our output is, it couldn't find anything basically. Nope is exiting early. Right. Here. So looking for results for remaining in past, else nope. It's a very, very complicated, very deep and meaningful debug strategy. Otherwise, we output it. But if I edit 3 AOC, so that mul is the first thing in the line, and then we run it again, and we run 3. Oh, it didn't work this time. Oh, interesting. I could swear that yesterday when I tried this, did I save it? No, it's definitely not working. Okay, I must have changed it. All right, let's go back to the original. And we're going to figure out why that parser isn't doing its thing. So we've got take until mol with an open parenthesis, then digit 1, which is basically 1 or more digits, a comma, digit 1 again, and a closing parenthesis. These are the things we're looking for. And if we look at 3 and find the first mol, it should take those characters, then a number, then a comma, then a number, and then the closing parenthesis. And it shouldn't take anything else. So take until, I thought, would read up till that first mol. But it seems not. So where am I going astray with that? This is all very new territory for me, so it might take me a while to figure my way out, but let's go DRS nom. And take while is interesting, but take until. Okay. Take until. Complete take until. Streaming take until. Which one am I using? Complete. Oh, the non-empty input slice up to the first. Interesting. No, because you want 0 or more in this situation. Take till. Oh, that's slightly confusing. They have a take until and then a take till, but never mind. I wonder, is take until the right thing here? I remember looking at Chris's version when he was doing it with part 2, but of course I'm not watching anybody's part 3 yet till I solve it myself. But I remember he used, it was like new line and then just starting the read right after that. But that's because the useful data was right at the beginning of the line. So we don't want to use that now. Let's just look at take until and its example. So take until EOF. With this one, it should return EOF and then hello world, which makes sense because EOF is right at the end. With this one, oh, this is until EOF. Oh, I see. That's the function, right? Okay. So it'll return an error kind take until if it can't find the string at all. The empty string, it'll return that. And for EOF, it'll return the entire thing after 1 if you pass it that. Okay. So I feel like, oh, I think I know why. It's because I've got nothing at the end, right? So it's matching all of this, but it's like, well, what do I do if there's something after it? So is there a way to ignore, I wonder, is there a way to ignore the rest of the string, or at least find multiple matches of it within the string? And yes, I think there is a cleaner way to type this return. I probably need I saw Chris using a custom type for this. So I think I might do the same. In fact, I wonder if I could do it now, like type mul statement equals and string char and string char. There may be a way to create just a single and string out of this, but I don't know what that would be. Okay, badness. Oh, right. Lifetimes. Got it. I wonder if this will work. Oh, wait. I see. So I have to, you know what? Let's reverse out of that for now. We'll come back to that. Okay. So yeah, there's bound to be some way to combine these into a single string. I just don't happen to know what it is. So how do we deal with that, the bit after the match? I mean, you could do take into a new line. I'm wondering about how do you find multiple matches within a larger string? I feel like that's something I can use the LLM for. We've been playing around with Claude a little bit after a recommendation from someone. It seems to be quite effective. I am going to go for a dark mode if I can, though. But I don't know where it is. appearance. Here we go. Better. All right. So using, actually, let's get this. Using norm and given the parser how does one match more than one instance of this pattern within a larger string? So we want to try and learn about how nom handles multiple cases. Many O. Okay. So let's look at many. Repeats the embedded parser, gathering the results in a vec. Okay. This stops on error and returns the results that were accumulated. Okay, so if we've got mini O tag ABC, parser ABC, then we get an OK with an empty string. Is this for the remainder? I think so, right? Yeah. In a vec ABC. Okay. This is, I think, what we're looking for. Good. So let's try to apply that to our string. So we're going to need a way to store these. And that means probably a resource. Now, how did I name the resources in number one? Day one, I used specific names like ordered location lists, location distances. Okay, so I think we'll go with mol statements. I do wonder if it's going to try and make us develop a sort of a more complex parser gradually, but maybe we can do that. I know in previous years they've had like what do you call it? Like developing little interpreters and things like that. I haven't done it for a few years properly, but okay. So let's go up the top here to keep things together. Derive resource struct mol statements or mol. We could make it more general, but I think actually let's go with either past statements or just statements and then mol. And of course that doesn't preserve any kind of order. Well, maybe it does. It'll add them in the instance that it finds them, but it won't add any other things if we have to add other past statements later. But hey, let's take it step by step. So here we're going to be, I wonder if it's actually better to just add the pairs in the processing, like just add the tuples. Tuples? Okay, so it's going to be vec I32, and this will become, oh, we need to init the resource as well. So init is doing a spawn, but we're also going to app init resource past statements, which means that past statements will need to derive default. Yes, but mole will be red. Okay. So down here, this becomes many O mole. Now, there were two versions of that. I got the multi-many O. And what's your problem? Expected opaque type and enum. Yes, I see. So returns a function. Okay, good. So this is just using one line for testing. We really should be writing tests, but we're not yet. We are not yet. Okay. So now we should be able to at least get a result. So let's see what happens when we debug that out. I really need to fix this. Aha. Okay, so not quite correct. Oh, that's the remaining. So that is actually potentially correct. Oh no, past 0. Oh, that's not good. It didn't get any of them. Damn. That's unfortunate. Why, I wonder? What am I missing? Um, Interesting. By the way, can I open a window under here? No, I can't. I forget the key command for when you want the split to go in the other direction. Just want a little window under here to stop my portrait from interfering with things. I may have already bound it to something. Sway, open window, split window horizontal. No, I don't want your shitty little thing here. I just want a normal search. Mod B and mod V. Let's try that. So mod B is that. No, we don't want that. Mod V. Aha, mod V. Just to make this a little more legible. Very high tech, my stream. It just basically involves me dragging sway windows around. Okay. Okay. So, um, so why is it not reading? Mini O mol line. And mol is this, which is taken to a mol. Right, but we don't have a way for it to... I mean, it's not finding any of them. So that should tell me something. Taken to a mol. I wonder if this should actually be tag mol. But if it's tag mol, it won't ignore things at the start of the string. So what was Claude's idea about this? Yeah, I don't think it's got the right idea either. It's not finding one. If I reduce that first line of input, to just a mole. So delete O and then delete end of line. Whoops. Like so. Then will it generate at least one of them? Yeah, no, it doesn't. So remaining is the entire string. Damn. Well, that's no good. No matches whatsoever. Okay. Um, so we can undo that. That's absolutely useless. So what is wrong with my parser? Maybe it's not taken till. Maybe it's tag. So we'll just repeat that for the full line. Past nothing. And then we'll repeat it for the reduced line. Interesting. So that'll work. Yeah, that works nicely. But anything else, like if I add this, if I add foo, because you should always add foo, then it matches. Interesting. Okay. What happens if I then do that? This is what tests are for, right? It only matches one. Okay. All right. So and if I do this, it doesn't match any at all, right? Yeah. So tag only works when you've got something right at the start of your search string, unless there's something else. Maybe that's what take till would do. So if we look at take till, returns the longest input slice, if any, till a predicate. I see. So using a function, a closure. All right. So that's not what we want. If we look at take until, I thought take until was a good candidate. Does not consume the pattern. Returns the input slice up to the first occurrence of the pattern. So take until EOF. Oh, I see. It matches that. And EOF is the remainder. I gotcha. All right. So that gives us more information. That's good. So we can go take until mol and then tag mol. And now our return type is wrong. Because it wants string, string, char, string, char. But it got String, 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 char, string, char. Okay. All right. Well, we can but try the result. Interesting. So unfortunately, it does return that as part of the match. But it also gets what we're looking for. And does it select a remainder of any kind? Oh, there's a lot of matches. A lot of matches. Where's my remainder? Maybe there isn't one. Yeah, looks like there isn't one. Oh no, there is remaining. That must be the portion. Oh, but the remainder's got some mole in it. That's not good. So that's a portion that starts with select and then Y. So if we look at the input, it's selecting up to there. Wonder why. Because that first. So this one is not a match. This one is, though. So it's interesting that it's failed to get that one. I think it's returned an error here. No, because it's not returning an error. It's returning okay. So what I want to know is mole 956, 136. Did that make it into the output? I don't see why this is the remainder. So the previous one was 599, 184, which is that one. So it's stopped there. Why? Literally, why? um, hmm, tricky. Tricky. Hmm. We have partial success, but we don't have actual success. I wonder if I need something after that final closing parenthesis. It's like it should disqualify this. So that is not accurate, but it does seem to be the pattern that's breaking our other patterns. I wonder if it's the first time that's breaking, the first time that's it's encountered a pattern it can't handle, but I don't really see what. Is it the asterisk? Surely not. It should just ignore it. How far through the string are we? What column are we at? Oh, these are like, we're at column 2700. It's a long string. If we go to the end, we get 3073. Okay. So why is there a remainder? I would have expected no remainder. How can we learn more about this? So we've got take until mole and then tag mole. Is tag correct? I think it is. Is there such a thing as a take until that discards its thing, discards its match, or discards everything up to? Because my understanding of what they're saying here is that take until EOF will be part of the remainder. And we take the rest of it, or we match the rest of it. That's correct, right? The remainder is the first bit. Yeah, remaining past. Um, hmm. Yeah. So the remainder is the EOF. I think that might stop us from matching on the tag though, right? Well, we need like a take until but discard. um, is there a wait? There's a take until. Is there such a thing as discard until or equivalent? Take until and ignore its output. Using preceded combinator. Specifically designed for this pattern, it runs the first parser and throws away its result, then returns the result of the second parser. Okay. So preceded, take until mole, and then tuple. The thing is, we need the result, but we also need to ignore characters up to the match. What about ignoring characters up to the match? E.g., everything before mole. Recognize. Take until mole success mole. Where is it actually using recognize? It imports it. Yeah. Let's test that. So we don't have to finish in one statement. We can just, the remainder, and then ignore the match. becomes take until mole. But hang on, won't that consume? No, it doesn't consume it. And then the tuple, we return the tuple with the tag, except we do it on remainder. Right. We need to question mark that. Right. Kind of. We need to take the extra string out of there now. Okay. So what does that yield us? Okay, so we know we've got well, the patterns are right now, which is good. But what about that remainder? Yep. Same place. It's failing at the same place. Interesting. I wonder if there are some characters that take until can't handle. There's a block at the end that it seems to be failing at. Wonder what that is. Because that's good pattern, right? Like take until you get to there, and then consume mole digit, comma digit, char. That makes sense to me. Um, what I don't understand is why it abruptly fails when it gets to select whatever. Mm, doesn't consume the pattern. It will return error if the pattern wasn't met. I wonder if that's the issue. It's getting an error. So if we look at mole O, where is mole O? Not mole O. Many O is what I'm trying to do. We look at this, stops on error and returns the results that were accumulated. To instead chain an error up, see cut. Preventing alternative branch paths like with non-branch alts. Hmm. If the parser passed in accepts empty inputs, many will return an error to prevent going into an infinite loop. So I think that's what's happening. It's getting an error on that, on being able to find the next mole. And so it's just exiting. But why? Because we've got this. We've got this block here. And I think it's failing on this. And I think we can prove that by, whoa, what just happened? What the hell? Did you just format on me? What's going on here? Oh, man. What a mess. It's really trying hard to treat it like code. Please don't do that. Hang on. Let's create a line between here, then go select there, and then add this there, and then remove these lines. Okay, so we'll try and see if it stops at the same block or not. It doesn't. Interesting. So that chunk is enough to stop it entirely. Something about the pattern fails. So that was its original state. Yeah, and then it breaks. But we don't want it to break when it, because the whole point is that it finds ones that aren't malformed. What about this would cause it to error? It can't find the pattern. It thinks it starts to find the pattern, but it can't find the pattern. So it's done its take until, and then this becomes the input. So if I go DO and just assume that this is the original input, it should fail to find anything, right? Yeah. Interesting. And if I remove all of that to the asterisk, it should continue on its merry way. Yep. All right, so my pattern is not correct. I need it to fail to find on that one. And then continue afterwards. How do I get it to do that? How do I get it to fail gracefully? Like, I don't care if there's errors. What I care is that it continues once it gets an error. So many O is probably not correct. It said, this stops on error and returns the results. To instead chain an error up, see cut. I don't understand what chain an error up means in this context. Transforms an error recoverable to error failure unrecoverable. This commits the pass result, preventing alternative branch paths, like with alt. So with alt, test a list of passes one by one until one succeeds. Again, I need to ask the bot. How do I prevent nom from exiting, e.g. from many O if a parser returns an error. Alt and opt. Use alt to try different passing strategies in order. I don't really want that. Wrapping results an option to handle failed passes. Triple, sure. Take and tell. Try the normal passer first. If we find it, try to pass it. If that fails, skip this attempt. Skip until next. Oh. Skip until next. Let's look up that. Hopefully we end up with sort of vague understanding of, oh, really? Of what? Oh, I see they've written skip until next. Value any char. Mm. I'm concerned that it's just making shit up at this point. Parser for multiple patterns that continue even after errors. Filter out the none results from failed passes. I see. Let's look at general searches. Skip errors. I want a more nom-specific. Parser strings but fails on keywords. The parser below correctly fails when given a keyword. Failed because it counted a keyword does not propagate. You can use cut to prevent many O to explore alternatives in the failure case. You can only use cut when you're absolutely sure there's no recourse. Thing is, I kind of want the opposite. I want not immediate fail. I want just ignore failure. Hey, zombie, how you doing? And Woodstone, how are you all doing this morning? Or this evening in your case? How is Dexter? Error recovery? The real reason is your test expect behavior is flawed. Is a slobbering mess? Excellent. Getting emotionally ready for work. I started 2 hours ago. I feel like there's something backwards about that. I feel like there's a hitch and there's a flaw in the plan. This is not helping. I need to understand struggling with NOM's error handling. It's easy to build a parser with it that works correctly. It passes what you intend it to and no more, but making one that produces useful errors is non-trivial. All consuming, separated list, multi-space. What about recognize? Let's understand recognize. 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 If the child parser was successful, return the consumed input. But see, what I want is kind of the opposite. I want it not to care about the errors. Append error, convert error, from error kind. How about nom, ignore errors? How to handle errors. Descriptive errors. I don't want descriptive errors. Error recovery is irrelevant. Tips on non-end errors. I don't want good informative errors. I want to ignore the errors. Hmm. Confusing. Many till. Interesting. All right, let's look at many till. We will understand this eventually after many tills. Applies the parser until the parser produces a result. I wonder if you could use like many till new line. Just go all the way to the end. Many till tag, tag end. Interesting. Keeps going so long as G produces error. And what is G? F and G. Hmm. Let's go back to Claude's example. Using Alt to try different parsing strategies. I don't want to do that. Wrapping results an option to handle failed passes. I mean, we could swallow the error kind of. So we could check the parser. And then just return an empty string or something like that. The important thing is not to fail the parser if there's an error. We want to be tolerant to the error and just continue to the next one. Curiouser and curiouser. So what's my search? Nom many O. Ignore errors. Mapping a passing error into an OK result. There's no comment, it returns an error. Oh, we got ads in a sec. I would like it to return an empty string instead. You could use optional to pass 0 or 1 line comments, or many O to pass 0 to many. Then combine that with preceded and we can easily discard 0 to many comments. Interesting. Let's consider a simple pass indent. Let's say we want to skip 0 to many white space and comments beforehand. Change pass indent to use preceded and many O. Skip anything that is ignored. Identify a passing. Excuse me. So let's look up preceded. Actually, I am going to take advantage of this ad break to get a cup of tea. This is my very complicated announcement. I'll be back. I'm so high tech. All right. Let's see what else we can do here. Now, so preceded, I think it was. Preceded. Preceded, that's not how you spell it, but close enough. Matches an object from the first parser and discards it, then gets an object from the second parser. Interesting. But does that preceded tag ABC, tag EFG? Well, Basie, is that you? By the way, is me vibing game dev. Oh, hey. Or if it wasn't that, it was Ben the developer of Bread Monsters. And hi. Do you like to change your Twitch tag occasionally? Well, hi. Oh, and thanks for the follow. Probably again. Yes, you do. Excellent. I'm here for it. I changed my GitHub name just recently. I kind of hate it because it's got a dash in it, but I had to because I'm never going to get Basie back again. I used to own it, but I'm never going to get it back. Oh, you missed me. That's very nice of you. I missed you too. I missed everybody. I really want to just stream all the time, but it's kind of tricky. So it's saying skip anything that is ignored. Identify a passing. Sprinkle that preceded in various passes. As long as you simply want to discard the white space in comments, it's relatively straightforward. And you could implement pass error. And from external error, use terminated, Alt and mini O. You're training in shadowboxing. Doing workouts for 1 hour, so in the future you can be a boxer. What? That's crazy. I have no experience of this. Is this something you've always wanted to do? Opt to pass 0 or 1 line comments, or many O to pass 0 to many. The thing is, I want not to fail if one of the things in many O fails. I just want to always read it, basically. Really wish I could ask someone about this, because the LLM is really not doing the trick. I mean, it's kind of got a solution, but I don't like the solution very much. It feels like there should be something built into Nom that I'm just not seeing. Let's look up opt. Oh, it is. Your dream is being a boxer. Wow. I have absolutely no history of this. Are you aiming for a particular weight class? Like, I know you have to be, depending on your kind of genetics and so on. Return none on error. Oh, could I wrap Could I use mini O and then wrap it in opt? Um, can opt take the wrap my parser to stop many O exiting on error. Okay, so this is looking slightly more like what I was thinking. And then opt tuple, and then many O, flatten collect. Yeah, okay, let's proceed down this way because I think that's more sensible. So if we go on 8, if we wrap that in opt, oh, it's not there. Don't tell me it's made it up. Nom combinator opt. Okay, we got a type issue now. So instead of doing that, we're going to return an option, which is fine. That's better. And then we need to flatten the results. So past is going to be flatten collect, right? Intuitor, flatten collect. Intuitor, flatten collect. Yeah. Can't do it. Iterate is lazy and do nothing unless consumed. Damn. Um, what about map string from? I bet this won't work though. The problem is the return signature. So this business of combining char and str. Let's see if we can figure that out. Nom return str char combine some combination of that. Argument templating. That's way too much information. How to create a str from char. Yeah, I bet I think this is the problem, is that it's, I doubt that string from will work either. But let's check. Yeah, because it's too many things, right? Um, How do I combine all of those things? Obtain a string from string, string, string. How many strings? 2 strings. Char, string, char. So we need to understand about combining these things. I think templating would do it, but I want to see the correct solution. Recognize. Interesting. Okay, that might be it. So we've heard about this combinator several times, right? Is it a combinator? I think it is. Should be a way to format these a little bit more sensibly. They're quite hard to read. Now the return type will be wrong. Interesting. So that was, yeah, that's way better. Now this, yeah, from iterator string. So we need to go map string from as Hexorg showed me the other day. Still doesn't work. Type annotations needed. Yes, because we need to do collect vec underscore. No, bad. Oh yeah. Wait. He showed me how to do it. Let me get the Discord. Let me get the Discord. He demonstrated this for me when I was confused. Many confused. Was it under using Rust? Oh, maybe collect vec string. Like so. No rules expected passed while trying to match sequence end. What? Oh, I don't think you can do that with debug, right? So let out equals. Expected argument list. Surround the type parameters with angle brackets. Aha. All right. Confusing, but doable. By the way, can I just do this? Yes. Okay. So now we run it and see what the hell is going on. No. Yeah, basically nothing. Nope. Oh, hang on. No, that's true. So it's failing here because it doesn't hit anything that it recognizes, I guess. So let's understand a bit more about recognize. And let's also rescue our teabag because the teabag has sunken. And you know how much I hate it when that happens. Aha. I have rescued the teabag. Excuse me while I dunk. If the child parser was successful, return the consumed input as produced value. But what if it wasn't? So why is recognized valuable here? Oh, because it creates the string. It creates the single string reference, str reference. But it's also failing to find anything at all. Hmm. Okay, so we've gone from kind of getting some matches to not getting anything at all. We take until mole. Is it possible that we're erroring on that? No, shouldn't be. And this passing business is no joke. But I shall not be defeated. I shall overcome. Hmm. It's not that it's not that it's not finding anything, it's that it's returning with a failure here. So it's not like it's producing an empty string output. It's failing on this call. So many O mole line is failing. And I feel like it wasn't failing when we didn't have it wrapped in opt and recognize. So what error are we receiving here? How do we find out more about that? Chris did this really cool thing where he instrumented the function so that you could see what the returns were and all that kind of thing. I wonder if we could do the same. Maybe we should watch that video real quick. Where are you, Chris? Help me. Help me. Help me, Obi-Wan. Did we do it with day 1 or day 2? I think it was day 2.
Or we could just do, a negative or a positive.
Okay, let's
If
see
it's
if we can
negative, it's obviously
find
producing. If it's positive, is obviously not. And say parse failed because of this. And then we return
instrumentation.
that in case this whole thing fails. So we can debug this out
Inspect.
and check our reports here, the right safeties here. So some interesting things we can do. We can map here instead. And we can
Tracing
check safety
instrument.
report. So this will map it into the actual safety value. And then we'll have a safety value here, which we can then debug with inspect, which has no side effects. This will then become a safety value. We actually didn't implement debug for safety, so we can go do that just by doing derive debug, and then our debug here will work. And then safety is a shared reference here, so we can just do a shared reference. And if we run this, we get a whole bunch of safes and unsafes.
Yeah, but
And if we
let's
run this
look
on our
at
test,
the
we get.
instrumentation.
So let's do this. Let's say debug the report, but instead we could probably just instrument this. An instrument comes from tracing, and let's get rid of this debug because we won't need it. But notice that even as we remove that inspect, we can just leave our filter and map here. So we run our code again, we get our faulty output. And that gives us a whole ton of output.
Whoa.
That's mostly because we're not skipping the input in our first tracing wrapper here. So this input is getting added as.
Hang on. So let's try adding this. I'm curious now. Let's add it to this. I may not have this enabled yet. Okay. Just curious what happens when I do that, like with nothing, no other changes. Nothing whatsoever. Okay.
As context to everything, which you can kind of see here. Like our check safety log has the report and whatnot, but it's also including all of that input. So just get rid of that. And now we start to see info logs from our check safety function with the report. And if we go back down to our check safety function, since we're already logging the input, which is our report, we can also log the output, which is the return value. So again, what I'm doing here is rust log equals info, which is part of tracing subscriber, which we haven't.
Ah, okay. Still nothing. Let's do this. I think there might be something you have to do to set it up. I'm reasonably sure. Is there the code from the video? Let's see what he was doing with tracing. No. Tracing subscriber format init. What does that do? Install a global tracing subscriber that listens for events and filters based on the value of the Rust log environment variable. Aha. Okay. Aha. Now we're onto something. Okay. So that's how you get tracing out of a function. That's pretty cool. We learned something. I am happy about that. Oh, it panicked too. It's not quite what we wanted. Did it actually panic because of tracing subscriber? That's certainly weird. Why don't we move this into main? Okay, well, that still works, but now it... Okay, so let's look at this. That's mol. That's the return type. Info mol, return okay. Info mol, return okay. So let's look at this block in a file. So the info is the name of the function, I think. Oh, that's the input. Okay. So can it match this for me so I go to the right place? Oh, that was the input? So what is this? And the return is okay for this. And then none. Huh. Okay, so it's not matching anything, basically, is what we're saying. All right. We could skip the input. What was his way of doing that? Instrument skip input. So how do you do that but also get the return type? If I go quit, edit that, and then day 3, instrument skip input, kill that. But now I don't have return. Can I comma return like that? Nice. Okay. So now I've got the return type only. Now that's pretty useful. That's returning okay with the remainder and then none because there's no match. I'm assuming that's because recognize is failing somehow. That would seem to be the way. Because that seems to be the thing that's newest. Optional parser will return none on error. So there is an error. What does recognize do on error? If the child parser was successful, return the consumed input as produced value. So for example, if it got separated pair alpha 1 char alpha 1, then it would okay on that. But if it was wrong, it would error. Okay. So that seems fine, but we're not getting anything at all. Is it failing to combine all of these things? Is that the problem? If I take away the opt, will it give me a better idea of what the error is? I'll need to change this. And then this will be wrong. So we'll get rid of that. And we'll see how badly it breaks. Oh, it works perfectly up until the same old place, at which point it fails. At that select because of this asterisk. So it fails at the first broken output, basically. And by using opt, wait a minute. Maybe this is working. We look at all of the return types and just go back far enough, we should see where it breaks. Try again. We go back far enough, we should see some matches. Yeah, some. 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 And then finally a nope. So it calls it many times and then it exits. Damn it. Which means that remaining and past are never assigned. So this eventually returns an error. So we're still not quite there. It's kind of nice that it's... What if I wrap the many O in an opt? But then it'll still just return none instead of me getting the results that I wanted. So again, Claude was wrong. Despite it trying its best, it was wrong. Where even is it? We're evaluating the AI at the same time, trying to use it as a learning tool. But using opt like this is not helpful because many O fails. So, given this example, the difficulty is that even with opt, many O eventually fails when it encounters... I don't know, when it encounters the none, I guess. Wait a minute, that can't be right. Because when you look at it, it has multiple nuns. Some, none, none, only two. Wait a minute. Some, 599, 184, then none. Oh, these are both the same. So it's tried twice to evaluate the incorrect one and it's failed both times. And then it's given up. Oh, okay. Okay, this is a clue. This is a useful clue. So now how do we get past The failed input. Let's do a match. Some match. None. We could just do this with the error. We don't even really need the opt anymore. We would want to remove the mole. Discard it somehow. Is there a discard until or a Yeah, I don't think we need the opt. If we're going to do this, we don't need it. We can just deal with the error directly. So this becomes okay. And then everything else. What's your problem here? Okay. I'll deal with that in a sec. In the error case, what we want is to ignore the mole. So we need to consume it. It's a take until, but take until leaves the thing in place, right? So should I just take? Is there's such a thing as just take? Take and count bits. Oh, it's a count? No. Well, you could, but it doesn't seem very safe. Take till. Oh, that's the function thingy. I just want take while, maybe take until 1. Doesn't consume the pattern. I want it to consume the pattern. Hmm. Nom ignore or nom discard. Sequence matches an object from the first passer and discards it. No. Delimited, pair, preceded, terminated. I guess we could just repeat what we did with, yeah. So let r ignore equals take until. Oh, actually, we've already got the remainder, right? No, we don't. I don't want take until because it'll only go up to mole. What about tag? Maybe just use tag. I think I see. OK is going to return RP. Something like that. No, bad. Oh, this needs to be. All right, and then this is I need to ignore this part and then return the remainder in an empty string, essentially, or the remainder and then none. I can do this. I can do it. So what is it going to return if I don't? What is it going to return in the input? Just empty string? I guess so, right? So our empty string like that. But now we've got all kinds of problem. Unsupported proc macro character. Mismatch closing delimiter. What have I missed? Oh, I see. I think. No? Bad. That's correct. Uh-huh. Yes, that's not a thing anymore because it's already a vec, or it will be. Okay, now this, expecting a result. So first of all, we could swallow the error. It's going to be wrong though, because that needs to be remainder empty string. Well, that's badness. Badness all over the place. Just badness everywhere. So many badness. So what I was trying to find was something like let r ignore equals take tag mul remainder in order to consume the offending tag so that we don't try and attack it again. But that seems to be bad. What if I do this in stages? Nope, even worse. Oh boy. Unsupported proc macro punctuation character. What does that even mean? Hmm. So the task is to consume. Actually, let's see if the bot will help me debug the syntax. Correct. Type annotations in the following. Missing use statements. Ignored value. Oh, error. Oh. Did I screw that up? Partially. The ignored value in the take until results. What? Changing star to underscore for the ignored value in the take until result. Oh, look at that. I have no idea what happened there because there's definitely an underscore. Weird. Using the question mark operator instead of pattern matching in the commented out code. What? Oh, yeah. But no, it's still a problem. Implementation satisfying underscore nom error pass string found in the nom crate. I get the feeling that there's actually already a nom combinator for this situation. Meanwhile, I'm like 2 hours in. I still haven't attacked the problem because I'm still trying to load the parser. Oh my God. Yet, no, it won't properly compile. You're wrong about that. And I can prove it. At least I think I can. Yep. All right. seems likely to me that using the norm combinators rather than trying to match on it is going to be more successful. So what I need is one that does the first thing until there's an error and then does the second thing, I think. Which would be matches an object from the first parser and discards it, then gets an object from the second parser. Gets an object from the first parser, then matches an object from the second parser and discards it. Or maybe alt. So terminated tag, tag. If you get both of them, it returns ABC. So that's kind of what we're looking for. Only not really, because what happens if this one errors? Yeah, no. So alt tests a list of passes one by one until one succeeds. The first passer returns an error, so alt tries the second one. Alpha 1, digit 1. So digit 1 returns an error. Alpha 1 returns an error, so it tries digit 1, and then it returns the success from that. So can we use that to our benefit somehow? By doing something akin, hang on, let's get rid of this match. Doing that now. So that's now successful. So can we do alt? This is our first parser. And our second parser would be something like, I want to get the remainder, right? So I want to, it's kind of like I want tag, but I also don't want it to error if the tag is no longer present. But actually maybe I do, because if it's no longer present, then we don't care about the rest of the input, right? So tag mol should consume it and return the remainder. Am I right? Where does alt come from? Non-branch. I wonder why it doesn't auto input. Takes one argument, but two arguments were supplied. Oh, it has to be a tuple, tuple. Well, it compiles. Let's see what actually happens. Holy crap, did that just work? Holy crap. It kind of did, except that this Yeah, so it gets us past the error, which is great. But we've got one more problem. Huh, but it works, remaining nothing. It's perfect. Yes. Okay, let's add a comment. Um, if we get a malformed mole, consume the start of the pattern so we don't try to match it again. Is there a better way to accomplish this? We got some ads. Okay. We're learning. This is good. We're learning. So, how do I avoid it ending up in the input, ending up in the past values? I could just filter it out. And can we avoid it ending up in the past input? Yeah, someone will be able to point me to a better way of doing this. But in the meantime, this kind of works. So what we'll do is instead of nope, will be like failed to pass input line. And then we'll go past filter x equals mole. This will not be efficient, but it'll work. Collect. Iter. Okay. What am I doing wrong here? I'm doing something wrong. I want strings. Why am I not getting strings? Do I have to go mul to string? Hmm. Nope, still wrong. Okay, I can do that, but I can't do that. All right, I'll take it. Wrong filter. There we go. And the last one should be 133, 153. So let's go 133, 153. Oh, I don't even have it. Yep, 133, 153. All right, we finally got there. Okay. We got there. Happy about that. So now we need to convert each of these into I-32, I-32. So here, we will do something akin to getting the resource, which is going to be past statements. And we will go, that should be a res mute actually. And then past statements mute mul equals past header filter mul. Then map collect vec I-32 I-32. All right. Now let's actually do the work. So let's do the work. In our loaders, in our asset loaders, we have puzzle input asset and we do conversion. What's the problem with this? Comparison to empty slice using as empty. Okay. Call pass. Right. So we now need to split on. I wonder if Nom can actually do the I-32 conversion. That would be interesting. But let's not go there right now. So we need to split on parentheses and then split on comma. I do believe we could use regex, but let's just do the basics maybe. Let actually maybe it would be better to use We split on comma and then split both of them on parenthesis, or maybe we should use a regex. Is that the sensible way of doing it? Let's go regex 101. I thought you got into dark mode. God damn it. Where's my dark mode? Where's my dark mode? Maybe you have to donate to get dark mode. There we go. Regex 101's amazing. Rust. My test is mol 1, 2, 3, 4, 5, 6. And I would like, what would I like? I would like mol actual parenthesis group any digit. I think it's D, right? 0 through 9 in any script. It should be D plus, I think. Yep, that's correct. And then comma, second group, D plus, and actual parenthesis. Yeah, that's what we want. And GM is, I forget. Okay, so group 1 and group 2. This is definitely not going to be the most efficient. We could even use like character numbers, but let's not. Okay, so Rust regex. Let's just shortcut it with sample Rust regex. So we can see the syntax. I don't want a comprehensive example. I just want very basics. No, don't need that. Don't need that. I need use regex, which is a crate, right? Or has it been, it's been subsumed. It's been upstreamed. RE is regex new unwrap. Oh, maybe it is a crate. Last I recall, it was Burnt Sushi doing all of that. He's a good dude, Burnt Sushi. Okay, go down 68, blah, blah, blah. Let RE equals regex. Ooh, what's going on there? Lower code environment. New. Just a string. Yep. R. And our regex from regex 101 was this. Unwrap. And then finding matches and groups. If let's some caps. No, I don't need named caps. Well, I could use named caps. But I don't need to. Caps O and caps 1 is fine. Or caps O is the entire match. Caps 1 and caps 2. Okay. if let sum caps equals what? Regex? Re captures. X, which is going to be wrong. Let, this is probably quite unsafe. Let left-hand side I32 equals caps 1 plus let right-hand side I32 equals caps 2 pass left-hand side, right-hand side. Badness, many, many badness. If may be missing an else clause. Yes, you're right. Found unit type. If expressions without else evaluate to, interesting. So we could just match, right? I don't know. Or we could do, oh, let sum equals else. Um, hmm. There's a thing where you can ignore the nuns. What is that called? I thought it was filter map. Oh, right. This is pretty bad. Let's just see where we are. Yeah. So how do I... It's not filter map. Oh, it is filter map. Okay. Creates an iterator that both filters and maps. Returned iterator yields only the values for which the supplied closure returns sum. Yeah, that's the one. I'm not wild about these unwraps, but, you know, let's see what it actually does. And then we'll just debug past statements, mol. Nice. Okay, we're getting somewhere. All right. That's our processing. Holy crap, that was hard. Not to most people, but it was to me. But that's okay. We're getting somewhere. So now, oh, interesting. The YouTube thing is freaking out. Okay. What is the deal with this little callback, by the way? Invalid node type? So, what is the actual exercise after all that? What do you get if you add up all of the results of the multiplications? All right. So solve 1, we've done most of the hard work. Solve A, rather. So we want past statements is a res past. Wow, what is going on with Lua? past statements. I think we might need to update the editor. And then how do right, so for statement in past statements mul, let mute total equals 0. Actually, this should be left hand side, right hand side. Seriously, Lua is freaking out. So we got left hand side, right hand side, total plus equals left hand side times right hand side. Debug. It thinks, oh, that's a big total. Let's see if it's right. Oh no, it's too low. All right. Oh, you know why? Because we're only doing the first line. That was why while we were just figuring it all out. Okay, so this. I assume we're adding it up for the whole thing, right? Yeah, that'll be why. Okay, so we need to append for line in past rows. Wait, puzzle rows. And then this equals needs to be append. Is it append? I think it's append. Bad. Expected mutable reference found struct. Okay. A little complex, but that's okay. Okay, so does that get us a different answer? Let's see. This looks like a different answer. Yes, it is. Hey, we got there. Holy shit. All right, cool. So that's part one. And the passing was the challenge. The solving, not so much of a challenge. The whole point was to load it correctly. But that's good. We learned a lot about nom. We learned about tracing as well, which is really good. Continue to part two. As you scan through the corrupted memory, you notice that some of the conditional statements are also still intact. If you handle some, oh God, yeah, more parsing. If you handle some of the uncorrupted conditional statements in the program, you might be able to get an even more accurate result. There are two new instructions you'll need to handle. The do instruction enables future mol instructions. The don't instruction, of course, it's got an apostrophe in it, disables future mol instructions. Okay. Only the most recent do or don't instruction applies. At the beginning of the program, mol instructions are enabled. Okay. For example, if you get a don't and then a mol, oh, I see. So it's like a state change. So every time you get a don't, you stop doing things and then you do, even if it says undo. This corrupted memory is similar to the example from before, but this time the mol 5.5 and mol 11.8 instructions are disabled. Yes, because there is a don't instruction before them. The other mol instructions function normally, including the one at the end that gets re-enabled by a do instruction. This time the sum is 48. What do you get if you add up all the results of just the enabled multiplications? All right, cool. So we need to be able to pass the first part of the puzzle, but also pass the second. Probably using the same parser. It's tempting to tokenize it all and just say, hey, I'm going to give you all of the actual instructions without the junk and you figure out the rest of it, kind of thing. Another way to do it would be to have disabled statements and enabled statements. And then you can add them all for the first part and add only the ones that are enabled for the second part. I also need to understand how Nom's going to handle it in terms of uh, what do I do? How do I know which state I'm in? So, for example, if I get a do, I want to exit immediately and set a state somewhere. It's quite tempting to just do like alt mol, like alt do, alt don't, alt mol kind of thing. How would that look? Yeah, because it wouldn't. Huh. I knew that my initial implementation was going to be too naive to fit to pass the second part. That was just always going to be the way. Um, hmm. So I need to pass for do's and don'ts, beginning in a state of do. If I encounter a don't, I want to exit, set a value, and call and store the mole in a different place until I get to a don't, or until I get to a do again. So it's like kind of pass until don't, or take until don't. And you could portion up all of the sections that way. So you want to ignore everything out of a don't after a don't until you get to a do. uh, so you could actually process it that way, right? You could process it like, hey, let's get rid of all the chunks after don't and before do. And then the remainder, yeah, that would work. Let's look at that. So, um, you wouldn't have to get rid of them. You just have to understand that they go into a different place. Interesting. Okay. So refactor time. Hmm. Let's branch by abstraction here so we don't get too confused. We'll use like process two. And we'll run process two instead of process one. And instead of doing many o mul line, we want to break things up. We want a parser that takes until don't. And then a parser that takes until do. Hmm. So hang on, what does it look like? Because what if you get like a do on the first? If you take until don't, then the bit before it, which would be the which would be the take until the remainder is the bit afterwards. Hang on. I need to see this. Returns the input slice up to the first occurrence of the pattern and does not consume it. So if it's EOF, then EOF is the remainder. Okay. So if we had a parser that takes until don't, hey, oh, cool, thanks. Handy. Gosh, it looks like it came out of the arc, but I'm sure it still works.
Can you? I got a bright burn.
Hang on, baby.
Okay.
Okay. So actually what we want is take until don't, like that. Is that what it was? Yeah. All right. So that will give us the remainder. It will give us everything. The remainder will be the thing we're interested in. It will contain don't. So we'll have to tag that. So actually maybe what we want is tuple take until don't tag don't. Why is it a mismatch? Oh, I see. And then the return type will be wrong. So we probably want recognize. Hmm.
Your daughter's tired.
Oh, and that's good. He'll be happy. Yeah. So I'll probably instrument this again so we can see what's going on. And then we would call it, but we would ignore everything except for the remainder. But hang on, if tag don't will consume the don't, but it will also return it. I don't think we need to consume the don't because we're going to consume it with take into a mole kind of thing. I think I'm wrong about that. Okay. So that should take everything until you get to don't. And that block is the do, right? And then we need something similar for if and do. Actually, do may be a keyword. Yeah, pretty sure. Okay. Do it. um, and then Or maybe we'll just do like that. Are we allowed to do that? Yeah. Okay. So actually, I think there's a thing like a hashtag that you can use. Anyway, we'll figure it out. Okay, so we've got ways to get rid of those chunks. And that would return, if we use many on, for example, take until don't. Hmm. And then for each of those take until don'ts, except maybe the first one, you would process for take until do. Let's see how this starts to look. For line and puzzle rows, we're using many moles, so we definitely don't want to do that yet. Let remainder. Whoa. What is going on with Lua today? Equals many O take until. Wait, hang on. Many O don't. Oh, don't is the name of a function. Line. Wait, I can't use question mark in that function. What was it doing? Oh, else. All right. Okay. So that gets all of the blocks of don't, basically. Now the first one has to be assumed as valid until you get to, yeah, until you get to don't. So should we just output this or even so which is the bit we're interested in, the don'ts or the remainder? Maybe we should just output both until we see what's going on. Okay, we got an error, failed to pass input line. Return is starts with a don't. So this is the remainder. That's the first part, right? And then an empty string for the match. Whereas the one before it has got an empty string for the, has got a full string for the match and a full string for the remainder. There's only two of them. Is that correct? If we look at 3 ARC, there's one there, one there. One there, one there. That was quite a few of them. 1, 2, 3, 4, 5. There's 5 on the first line, 1 on the second, 2 on the second, 3. Okay. So there's quite a few. And it looks like we're failing after 2 of them. It's really quite difficult to, maybe we need a simpler. Failed to pass input line and then done. So once it got to there, it's like, yeah, we're done. And that string is the last one in the first line, I know for a fact. And then it errors out. So it's like I haven't got any more. Which is fine, but why is it erroring? For line and puzzle rows, let OK. Oh, because it returns, it should continue, right? So take until don't, and then it's going to error when it doesn't find anything. So at least this should get 1 for each line. Yeah, this has moved on to another one. And then it errors. Why does it error at all? Have I got an extra line? Or is the one without any don'ts? Or is the one with a malformed don't? They look fine. They've all got double parentheses. I don't think they've actually made don'ts have errors by the looks of it. And they all exist on every line. So why? Why would it error at all when it gets to the end of each line? In which case, why do I get debug output? Is there a, by any chance, no? Process 2. Okay, so why do we ever get here? We do get all the way to the bottom, right? So the last one is 627, 570 select. Yeah. We get all the way to the end. There's a space at the end. Maybe that's it. Just out of curiosity, what happens if I save that and rerun it? I don't see why it would be. No. Why does it error? Just when it gets to the end of the line, I guess. There's a thing that Chris was using, a new line. Maybe that would stop it from erroring. So if I look at don't, Oh, thank you, baby. That's nice of you. That's okay. So why do we get to the debug statement some of the time, but not all of the time? That's my question. There should be 1, 2, 3, 4, 5, 6 lines of input. So debug puzzle rows len. God, it would be right at the start of the input, right? So I'll probably never get to it. 6. Did I say 6? Yeah, 6. That's fine. So why the error? Weird. Very, very weird. What would cause it to fail out just when it can't find it anymore? How many times does it fail? Let's check and see if it fails 6 times. Let mute fail counter equals 0. This is so lame. I don't care. Oops, closed the wrong thing. Rust backtrace? No. Just debug, right? Was it Rust debug equals info? Could not set global logger and tracing subscriber as they're already set. Consider disabling log plugin. Okay. Oh, my info went away. Fail counter is 6. Okay, so it's failing at the end of each line. So it kind of expects to fail. So maybe we don't care about that so much. failure at end of line is expected? Question mark. Things we need to ask other people later. Okay, so we've got a series of. I really want to know what was it Rust debug? Rust debug level. It's going to be a flashbang, you watch. Yeah, but how do I set it on the command line? Rust log, maybe? Yeah, there it is. Okay. All right. So we've got a series of things that are split by the string don't. Now we need to process all of them except I think the first one. Because the first one has got don't at the start of it. And we want the remainder from that. Hang on, look at take until again. Does not consume the pattern. So it returns the input slice up to the first occurrence. So the first occurrence is in the remainder. So for the first one, we want the past value, and that's automatically put into the do pile. So for the first one, at least, we'll be discarding the remainder. No, we'll be processing the remainder to see if it has any do's in it. This is definitely going to break my brain. Okay, that's all right. It's okay. We're fine. We're fine. We're fine. For the first iteration, the past value is considered a do block because this is the default. So let's go let do's or dos is a vec string, possibly a vecstr, but we'll get to that. Equals vec let don'ts equals a vec string. Is it always the case that the past value is a do block? No. After this, we must check to see if mul statements are re-enabled with a do statement. There's probably all kinds of like interpreter passing knowledge that I could be using that I don't have here. Like tree, is it tree descent? What's it called when you basically dive into a statement? I did write a parser once, write an interpreter once, but that was many, many years ago. I'm sure this is probably good for me in some way. Okay. That means we need a counter. It's iter count or iter. I always forget. What is it? Enumerate. I always forget this. Okay. Fi is 0. Do's append push past. Oh, it's a vec, right? I think it's. I mean, it's interesting. Oh, because we used many. So actually, what we mean is do's push, do's O, do's push past O. Can we just do a vec answer? I can't remember. Okay. After that, for uh, for chunk in past slice of 1 to end. How does one do that? Rust slice 1 to end. I'm sure that won't work, but index from end. I think it's something like 1. I think it's something like that, isn't it? Oh yeah, maybe it is. So we have to check for any do's. Hmm. I think for this to, yeah, okay. So all right. So now I need to run do's across it, which is going to look like let some, no, let okay are P equals many, actually many? I don't think many. I think just take until, or even just do, and we're doing it on the chunk. Else continue. And then in this case, the remainder is the remainder the bit we're interested in? So we're taking until do. So the remainder is the bit we're interested in. We discard the rest. Or we don't necessarily discard the rest. We add it to don't, right? Oh, shit. I think it would be more efficient in this case just to check for the do's. So let's discard the found. Yeah. And then we want to process do's push R. Okay. So actually we're not going to store the don'ts. And we don't need I. All right. We're getting somewhere, I think. Maybe. Possibly. It's possible. We might be getting somewhere.
Yeah,
Yay.
he just dropped it on the driveway.
Oh, really? Shit. That's
I
not
had no
ideal.
idea. I had no number. I had no
Mm.
anything.
Well, at least it's here in one piece. Okay. So we at this point we should have all statements following do and the initial statements before the first don't. So that's all in do's, which is a Vic and str. So now we ought to be able to grab all the past ones, grab all the moles. I think. So now we go for chunk n dos. And then this becomes mini mole chunk, which I don't know if it'll even work. That does. And then we go mole append. So now, in theory, we ought to be able to get the second answer, but I'd like it to be able to do both. We could get it to do both by processing all the don'ts, but I feel like this is probably... So solve A and solve B are essentially the same. Bark, 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 bark. Dog is mad because someone walked past house. How dare they? How dare they? How could they possibly dare it? Okay, so now we're running process 2. Actually, don't know if I've got this right, but let's just see what happens. Turtle O? Yeah, no. Okay. So let's think through this then. For example, how many do's did we find? Instead of debug remainder past, I want to debug do's. Was that do's? No, these are all the tracings. All the many don'ts. Is this even getting called? Oh, that's in the for loop. Let's take the tracing off there. Mini mole chunk. Else failed to pass input line. So it's reasonably suggestive that there isn't any do's. There aren't any do's. Let's check that theory. Do's are empty. Okay. We don't find any do's. Oh, let's see what the deal is. There are definitely some do's. Multiple do's in the first line. So maybe I'm saving the wrong bit. maybe I'm saving the wrong bit. Because we are not finding any do's. There should be at least one. Actually, I think this should be the remainder. But only for the first iteration, which is why we needed that count. Wait. Huh. Which is the remainder when you're using many? Hmm. Is it like a composite remainder, or does it just take the first one? Still empty. So the remainder must have been empty, right? So how is the remainder calculated when you use many O? Stops on error and returns the results were accumulated. So I guess it's saying, well, I've got all of the things. Actually, with take until, the past value is the one you're looking for, right? And the remainder would be don't something. So past O should be correct. In that case, why is there nothing in there? We're not succeeding. We're not getting anything. Or it's continuing because it's failed. It's gotten to the end of the line. Yeah, that's what's going on. It gets to the end of the line and it continues. But we don't want it to do that. So that presumably means that nothing happens here. Wow. Yeah, we never get to that point. Okay, well that explains it. So how do we avoid that error? Using opt? That doesn't sound right. Why does it error when it gets to the end of the line? It's like, I'm done. So in that case, we would get 6 end of line. Something I'm missing about the way NOM behaves when it can't find its next thing. Yeah, we get all 6. Okay. So that's what's going on. How do we avoid it? See if Claude can shed some light. Using a mini O, take until oo, input parser, an error is returned on end of line. How can we avoid this since the error is essentially expected? Your preferred approach. Rest. Oh, or alt. Okay. Okay. I'm picking up what you're putting down. Okay. This is what we were looking for in the previous one, really. Okay. So if we look at don't, for example, this should be terminated. Take until don't. Wait, does it need a tuple? Yes. Wait. No, it's just a function. Rest. For some reason, it's struggling to do imports today. I don't know why. Combinator rest. All right. So we're saying take everything until like so. All right. So now, do we get the end of line debugs? No, we don't. Okay. So this is way better. And we get a number. What's more, I wonder if the number is actually accurate. That would be hilarious. Is it less than the previous one? I feel like it is actually. Nope, it's too low. Okay. So good. Progress. We like that. We like a bit of progress. We're happy about progress. So we get the past and we get the remainder. So many don't line, else continue. We're not continuing, so that's fine. And this is no longer true. We should probably info unexpected line pass failure. So I'm gonna stop saying that. I need one of, if I could afford it, I'd use Woodstone strategy, but I can't afford to hand out subs every time I say a word. Just can't happen. I'll never buy a chair. Okay. For the first iteration, the past value is considered a do block because this is the default. After this, we have to check to see if mole statements are re-enabled. Okay. And then we go for chunk in past 1 to whatever. look for the do's, or look for a do, else continue. And that would give us the remainder. Do I actually need the past value instead? I suspect I do. That's the same number, isn't it? I'm pretty sure. 571,84716. Yep. That would be the same. Okay, we won't attempt that again. That's interesting, though, that it made no difference. Why did it make no difference? I feel like I've missed something crucial here. For chunk and do's, did OK past mini mol chunk, else failed to pass input line? And actually, we could use rest with mol as well. But let's not do it right now. So past iter, filter for mol, or filter for an empty mol. And then do the regex. And it's too low, it was saying. It's debugging the do's. Actually, we should check those values, right? It's interesting that it's got when select do as the end. Oh, it's not the end of the statement. That is weird, actually. Why has it got... Shouldn't do be the very beginning or the very end? Man, this is breaking my brain. Returns the input slice up to the first occurrence of the pattern. And the pattern occurs in the remainder, or begins with the remainder. So if I was to output the remainder, I should see... Let's get rid of this. And we should see debug R. We should see a whole bunch of things starting with do, in theory. We do not. Man, that's weird. I bet I was processing the wrong thing. Still the same number. And now their P's are... Yeah, those are correct now. So if I look at this, and I debug R here, Do I then get a string of do's? Hang on. Something is not going according to plan. No debug output at all. Did I get failed to pass input line? No. The chunk in past one start. Oh, so there is the none. Maybe there was nothing else. So maybe it just returned one instance. Yep. Okay, so that's the downside to using the terminated thing. You only get one of them. Bummer. Did I misinterpret what the AI was saying? Oh, terminated many. Right. Okay. I misunderstood. That was my fault. Okay, so what we actually want is this. And potentially this as well. But no, because we've changed things with mole. It does something different. Total zero? Unexpected line pass failure. Okay. So that still returns an error. Terminated many rest input. We get a vec of all the chunks, including any final tear cast of the last foo. But will you? Because I disagree with you. Many take until foo. Rest. I mean, what happens if we just do it this way? So that we just remove any possibility that I misunderstood. What did I do? Oh, pain. Pain. I think it's making shit up. I'm not certain your your terminated suggestion is correct because I still receive the following still exits with an error at the end of line. Where don't is defined as take until fails if it can't find the pattern. Yeah, that's what I'm saying. So you're saying alt now. Okay. I'll go along with you. Now it doesn't want me to. Oh, yeah, because we need a tuple. Rest to be a function item, and it is not because it returns result string error as opposed to result vec string. Ah, okay. So again, you've led me down the river, haven't you? Oh, I see. Alt has to go and so okay, I'm with you. I'm with you. I'm with you. So this has to go away. This has to go away. This becomes alt rest like so. All right, let's see where that gets us. Still failing. So I think you're full of shit, AI. I think you are 100% full of shit. If we can't find don't, just return whatever's left. Oh, because you're using the fucking. I can't use the question mark operator. I need to handle the error. God damn it. Please notice that you have used the question mark operator to handle the error from don't. This does not avoid the error at end of line. Yeah, but ugh. What did I do for the previous one? What did I do for mole? I did take until, then recognize with alt, and then tag. I don't feel that Claude has particularly improved my chances of solving this problem. I'm really just trying to use it as a learning tool for Nom, but I feel like it's just not. What about Nom fail at end of line? Read to end of line, or is using Nom a bad idea? Whoa, flashbang. Dark mode? No, sorry about the flashbang. Ideally, defining a pass would look like comment. Nom is pretty idiomatic to use. Terminated char in. Preceded. I've seen people talk about Chomsky too. Delimited, tag n. Pest, Chomsky, and Pom. So if I use delimited, will that stop it from failing at the end of line? Let's test that theory. But the difficulty with me is the many thing. But maybe first, second, and third matches an object from the first passer and discards it. Oh, I see. So that would be for like surroundings, basically. Finally matches an object from the third passer and discards it. That actually could work. Like that. If you see what I mean. So the only thing would be if you weren't dealing with a full line, it wouldn't have a new line, right? It would just be end of string. um, but you could use rest, I guess. Okay. Just check. Does that give us any difference? Panic. Index out of bounds. The index is 0. Okay, so we don't get anything, basically. Oh, take until is wrong here. I think. I'm really starting to feel like norm is the wrong solution. At least for someone who doesn't understand norm. So take until don't is wrong, I think, because let's look for delimited. So the simple option is obviously parentheses. But you need to be able to get rid of all the leading strings as well using take until. Sorry about the flashbang again. Terminated might be the one. Which I think we've already tried. Gets an object from the first parser and matches the object from the second parser and discards it. But that's the thing. It's not always terminated in new line, right? Ugh. This is so frustrating. Because we have to match multiple instances of it. And only one of those instances will be tagged with a new line. Seriously makes you want to reach for regex again. This doesn't help because if it's an error, then we don't have the past values and we need them. So it's actually full of shit. Consider the situation where multiple foo must be identified within, say, foo ABC, foo DEF, foo GHI. New line. How can we structure passes so that the end of line does not cause an error? So you're saying until foo, take until foo input, then get the remainder for foo, and return remain and found. And a list sequence of those in, plus any remaining text at the end. Opt until foo. Hmm. Find it difficult to believe that Nom doesn't have a simple way of handling this situation. I mean, maybe it does. Maybe that's what delimited is for, or terminated. Let's take some of these ideas and run with them. We're now going on close to hour 5 of trying to understand this, but that's okay. Let's figure it out. So you're saying take until your target and then grab the remainder and ignore it, or grab the tag and ignore it. And then return the bit without the tag. I don't really care that we're ignoring it, but slightly weird that there's a redefinition of remain here. Like, is that even legal? Apparently so. Okay, so that gets you everything after the don't and everything before the don't. So first we start with past O, which is fine. It would also be good to understand how big the past chunk is there. So let's just see what that change gave us. Interesting that I think that solution is the answer to the first part of the problem. I'm pretty sure it was 17 whatever. Let's just check it. Too high. Yeah, so that would have been the answer to the first part of the problem. So it's interesting that the remainder does start with a do this time, which is what we were expecting. That's better. Um, so actually it should be do's push R. This is a new number, which is interesting. Is it less than the first one? I think it is. Probably have to wait. Don't know if it's been a minute. Too high still. Please wait 1 minute. Oh yeah, there's the puzzle answer there. So 173419328, and then I answered 283884. Oh yes, that's way too high. That's more than the previous one. Okay, so let's look at our logic again. So it's not dying, which is good. We don't need to debug R anymore, I don't think. We're getting the remainder from everything starting with do, which is good. What was past length? 6. Is that correct? If we go 3 AOC and we look for don't, we get 1, 2, 3, 4, 5. Yeah, that's correct. So there should be 6 chunks. We got ads in a sec. I'm probably going to make another. Oh, no, I've got enough tea left. Should do another team shout out. Hypnotic. Go Hypnotic. Okay. So we must check to see if mul statements are re-enabled with a do. Right. So pass length is correct. We can get rid of that. The chunk in pass 1 to end. Remainder is the do. So take until do. Else continue. Oh, I bet the remainder contains all. No, it should only contain what's in the chunk. So everything up to the next don't statement. Do parser errored out. Oh, yeah. Okay, well, that's not good. Where is it? Should it matter? I mean, if it end of lines, that's probably fine in this case, right? Debug do's length. $18. Is it accurate? It's interesting to me that do's length is 3 on the first pass, on the first line. So there should be 6 of these, and there are, but why only 3? One, two, three, 4, 5. There's 5 on the first line. And that's not even including the bit at the start. So it should be 6, I want to say. So it's exiting early? Hmm. Maybe I need to use that approach that I used for the other one again. So that would be let. I think I'm just going to use R and P because that works for me. Same result. No difference whatsoever. So it must be exiting on one of these lines, I think. So if you do a take until and there's a new line, I think it's still going to fail, right? But that would be good because you don't actually want anything after the new line, I guess. Man. So since that doesn't make any difference, it should continue at this point. Once it reaches the end of the line, that's fine. Um, because if there's no do in the chunk, then we don't want it. So if there are 6 chunks, it doesn't mean that there is a do within each one of them. So I feel like we actually need to see what's in the chunks. And we can copy that out. Whoa, that wasn't what I meant to do. Oh, so very slow. All right. So the first one, there is no do's. The second one, there are no do's. The third one, there is a do. The fourth one, there is a do. Two do's. Ah, okay. So that explains it. Three do's in the fourth one. And no don'ts, right? If we've got a don't in here, we've failed. Definitely no don'ts. Okay, so that's good. That's promising. So interesting. So actually, all we care about is that the first one should just go in regardless. And that should have at least 1 mole in it by the looks of it. The second one, we take everything, we don't take any of it. Oh, so if, right, it's not guaranteed that it's there. But that's good because, is it? If it fails, we don't want it because it doesn't have a do in it. So we actually only want these ones. So everything from here back should go away. But then everything from here forward should be retained and processed. Okay. And then we keep the remainder because that's the bit that starts with do. Oh, we should have taken that out. Okay, but it definitely starts with do. Is there only 4 of them? Actually, that sounds right because the first 2 lines didn't have any. So there's only 4. So that begs the question, why is the total so high? Am I counting twice? Which I can do's. That okay. And we're looking for many mole chunk. Is past wrong here? No, I think past is right because it's take until. So we get the first one, we dump it in. Then we look at the remainders, the rest of the past blocks. We don't look at the remainders, do we? We get the first one, and then there's a don't, which we've discarded. Absolutely infuriating. I just don't know. How are we breaking this up? Every iteration of, well, for starters, have we confirmed that we're getting the right things? I think we have, right? Like every remainder starts with a do block. That says something. That says we're getting the right bits of it. I mean, one thing we could do would be to pass it manually and then compare what we get with what the program gets. I mean, we should be using tests to do that. There's no question about it, but I feel like I'm down the rabbit hole now. Hang on, let's write this to a copy. All right, so we look for don't. That's our first don't. So wait, what? Okay. And then it would remove that. And this is the first passed block. Except there's more than one don't, of course. So this is the first one from the first line. So we don't actually delete that bit. We take it. That bit is valid and should be processed. Then we look for the first do. We don't find it in this block. And I don't think we find it in the second block either. That's our first one there. So if we go back from there, anything before that should be ignored. Yeah. So if we D0 from there, let's just remove all of this. Okay, so that's what we end up with. There are 1, 2, 3, 4, 5, 6 lines. And one thing we could do would be to run the original parser over that and see what we actually get. but so there's no do left apart from the ones at the beginning. Oh, whoops. Good. Okay. And for don't, oh, there is one left. Oh my God. Is that what's going wrong? All of that has to be ignored. And now they're all gone. And all of the do's are at the start. Okay, so that is the correct output set. That's what should be in past. So if we take what actually is in past, oh, and this is just for the first line, right? Jeez. Okay, so we've got that in sample AOC. So now past, I think that was just for, that was for everything though, wasn't it? And this is the input. So if we temporarily delete everything except the first line of input and then run this and output past, or output do's, in fact, I think would be the way to go. And then see what we get. And look at the difference, basically. That's looking promising for the first one. Not looking real promising for the second one, which should finish with that. Ah, I see. So this just hasn't been separated, but it should still be valid, right? Okay, so far identical. Oh yeah, we're definitely missing some. We're missing everything after here, and I think it's probably after this line, so we're missing these two. Probably because we've counted some don'ts, maybe? They're not in here. But we're also missing all of this. Huh. What is the last character here? 981, 964. So yeah, we must have a failure somewhere there. But that would lead to a larger total, wouldn't it? Are we looking for a smaller total? Just out of curiosity, is Chomsky actually easier to use? Recursive descent passes. Example brainfuck parser. Oh boy. Tutorial. High quality errors and ergonomics over performance. Be easy to use. My apologies to Gnome. Yeah, fair enough too. All right. Let me using Chomsky, demonstrate a parser for ABC foo df foo ghi extracting instances of foo. Get any text. Look for foo and discard it. Oh, that wasn't quite what I meant, but never mind. Use repeated to find all instances. Interesting. Hmm. Okay, let's persevere. See if we can get there. But it's good to know about Chomsky as an option. All right. So we can see that the output that we create manually is different after about the third. After this line, it's different. And I think this line was the one where we found instances of don't, right? So if I go to 981964 in the sample, yeah, right after that, there's a don't. So that's where it's failing. So I must have misunderstood how the kind of the parser and remainder work in that instance. Is it possible that we actually want the remainder for the rest of them and only pass to O for the first one? Well, that's a good clue anyway. So we've missed a don't. Past contains all of the things before a don't. Remainder contains all of the things after a don't. In a way, it's almost like you should replace them, like switch them around. Um, what would happen if we did that? Just out of pure curiosity. We get another number, which is enormous, 564 million. And again, I don't think it's correct. I think we do have all statements following do. But do we? Because I think it fails. Oh, God. It fails after that don't. I think the confounding thing for me is what is the remainder from a many? So why don't we find that out? So the remainder is the first bit, I think, before. Well, that's actually tiny. Oh, it's the remainder on each line, right? So where's the first one? It's the bit ending in dash or hyphen hash. So it's the first bit, right? Yeah, it's the first bit before the don't. Okay. Well, that's what we need then, right? So do's push remainder is what's required here. So this should be just the whole of past. I'm not sure about this remainder business. I think I am because the remainder is the bit before, the remainder is the bit after the do. But it also suffers from the problem of not discarding the do. So is it likely to get it again? Let's just see what the change in behavior is here. Well, now it's enormous. 494 million. And the original answer was 173 million. Okay, so it's definitely not bigger than that. So let's display do's again. I'm pretty sure it'll have a don't block in it. Oh, this is for all of them as well. So we don't want that. We just want the first line. You can imagine if I'm having this much trouble with day 3. Okay. So now if we go to sample, we still have plenty of don'ts. My question is why? Why are the don'ts in here? Not on the first line, on the second line. Why were these not dealt with by the first parser? Why were they not dealt with here? Why are there still don'ts in there? Oh, did I flip that around? Did I not change that again? Yes. God damn it. Now we're at 367 million. Okay, so remove that and run it again. I feel like we're gradually trending down. Okay, so there's no don'ts in it anymore, which is good. That one was just bullshit, so we'll get rid of that. And it looks like we're still failing, yeah, on that 981, 964. So that's where there was a don't. Interesting. Many don't line. But there are do's following that point, right? So if we look at this, was it 987? Nope, can't remember. 981, 964. There was a don't there. And if we just cruise on through, are there no further do's? There's one. So there are further do's and we're missing them. But again, that would make the total higher. Seriously, at this point, I'm almost tempted to split the string on do. I want the parser now. I want to understand the parser. I want to understand it. Stubbornness is basically my only saving grace. Maybe it's not even that. We're correct about the remainder being the first do block. And then we have a whole bunch of pass to don't blocks. We should also check the output of past to see if it concludes the last part after the don't. I think it will. Oh shit. Still got the all the rows included. Okay, so the last bit is ending in 981964. So that's wrong. That's why we're not getting the rest of them. That's incorrect. So there must have been a don't here. There was, but we're not getting the rest of it. I need the rest of it. So that's part of the problem. So I need rest. I need alt rest. We're ignoring this. Yeah. So this is pretty flawed. But if I don't do it this way, I get an error. So if I do it like, say, alt, or even terminated, it removes the tag. If this succeeds, it removes the don't, and then it returns the thing. If it doesn't succeed, it exits. I don't know, man. I just don't know. I just want to see a compelling explanation for how it handles the end of line stuff. Exit with question mark feels like it's the wrong idea. So at this point, we can't find another don't. So I want the rest, essentially, which is what alt does, right? Like, what is the difference between doing that and doing this? It actually returns result nom error. Oh, right. But if I do that, it's going to exit at line 43. Right? Yeah, unexpected line pass failure on every line. And not having the values that I need. So isn't the solution just to wait for the end of the line and then like maybe it should be why does many O exist if it fails when you get to the end? Oh god. I don't understand. This is such a strange API. Test against a list of passes one by one until one succeeds. The first passer recognizes the input, alpha 1, and there's no remainder. The first passer is an error, so Alt tries the second one. And that's fine. So why am I getting an error when I use rest? Return the remaining input. Why is that an error? Sure, start a new chat. Under what circumstances can this non-parser return an error? I thought that rest simply returns the remaining input. The alt combinator will try take until first, and only if that fails, it will try rest. Take until will try return an error if it can't find its pattern in the input. The error would never propagate out. Rest is guaranteed to see for any input. Parser actually cannot return an error, but it does. Oh my God. Maybe it doesn't. Maybe it's erroring out for another reason, like the many. Hmm. Given the above definition, explain how the following can why the following displays the error message. Don't count fail. Many don't can fail due to infinite recursion prevention. Many don't, if don't returns a successful match. Oh. Ensure your inner parser always consumes at least one byte when it matches, or handle the empty input case explicitly. Okay. So how, so it's not failing because of the end of line, it's failing because of recursion. So how do I avoid that? Because that would make everything a lot simpler. The rest parser would successfully match an empty string but consume no input. Handle the empty input case explicitly. All right, well, let's detect the early input, the empty input. If input is empty string, empty. Oh, yeah. I don't see an empty. Maybe we just output the input and look for the last one. This is no longer about AOC. This is about understanding the parsing. So it must have duplicated the last two calls. It must be passing rest essentially twice. Leading to the recursion. And we can detect that by looking at the last characters of the input in the last two times. Yeah, that's what's going on. Well, that's something. And in fact, we don't consume don't, and we should. What we should be doing is something like take until don't, tag don't, and rest, I think. So tag don't will consume it. And that gets us, does that get rid of the error at least? Still ends with select. Still ends with select. And it still has don't at the front of it. So I think take until don't is succeeding. So tag don't is never reached. Okay. Given that, if we go back to where we had the other implementation, this one, which at least consumes the don't. And then essentially do do that, I think. Hmm. Oh, I see. So that should, P should no longer have the don't in it, which might be part of the problem. Okay. All right. All right. That's amusing. So it's not actually what we wanted. I can see why they were returning the other one now. Yeah. I'm actually wondering if what we want is the remainder. No, no, we don't. We want, we don't want that. That's just the word don't. The remainder of that one is everything after it. Okay, so we're back to that state where we're not erroring. but we also don't get the last bit. I'm wondering if we actually need something like can't even remember where rest comes from now. Combinator. Well, it's another number. It's still 367 mil. So this is, what are we outputting here? I've lost track after all this time. Past. Okay, so this is now ending in 858. Oh, that's with all of them though. Yeah, it's still breaking at the same place. So there was another don't there, and it's not getting it. This ceased to be about AOC like an hour ago, maybe 2 hours ago. Starting with do, but again, it'll finish at the wrong place. And it's failing to remove don'ts in the way that it should. I wonder if I should use delimited to just get do delimited with don't, or a new line. Well, I'm going to have to call it anyway. We'll figure it out later. Take it easy.